You might have noticed that the Next.js team's been a bit quiet lately, and that's not like them. Normally, we're hearing about new features and things being worked on constantly to the point where it's almost annoying. But since NextConf last year, things have been almost silent. What's going on? Is Next dead? Quite the opposite, actually. They're in the middle of making some really awesome big changes, and they're making sure they get them right before they share. Back in the day, I'd be part of that camp, hearing about these things, talking with them internally about it, and trying to figure out how to pitch it to y'all as best as possible. But in case you missed the news from last month, Vercel and I broke up. We no longer have a formal working relationship. I'm still a customer, I'm still a Next.js dev, but they have no control over anything I say, do, look into, or talk about. So while in the past, I might not have been able to dig into the GitHub to try and spoil features for y'all, that's not the case today. I have free reign to do whatever I want, and there's some really interesting stuff going on that I want to talk about. So Next 15 and NextConf are coming up real soon, and there's a lot of stuff that's going to be shipped as the main experience with 15, most of which we've talked about before, from TurboPack to the React compiler. Cool stuff. But it doesn't address the biggest issue I and many others have with Next right now: caching. The state of caching in Next is bad, would be putting it lightly. There's just too much layering and nowhere near enough insight on how the caching works. I think it's fair to say the situation kind of sucks. Between React cache, the Next unstable cache, the headers caching layer, as well as the database and Redis and other solutions you might bring in KV, whatnot, there are so many layers to the caching that it's easy to get confused and kind of lost. And I've seen so many people unsure of which to use, if any at all. They often result in things that either use way too much compute and are doing stuff they shouldn't, or things that are constantly out of date. Finding this balance sucks. And if anyone knows that, it's the Next team. They've been working really hard at trying to figure out how to do this right. If you're curious how I know they're working hard, it's pretty easy. Release tab on GitHub. This tab shows all the canaries they're cutting and all the things that change between them. So if you just scroll around, you can see what they're working on. They fixed wait until and edge runtime sandboxes. They fixed mark revalidate, did some stuff here with DynamicIO. Wait, UseCache, DynamicIO. What's going on here? UseCache as a string, add support for UseCache in route handlers. Oh boy. I was really excited to be the one to leak UseCache to the world, but I got beaten. Earlier today, good friend of the channel, Lee Robb, went live to show off some things going on in the new Next.js release candidate. And he showed something I did not expect him to show. I'm just going to play this clip from him so y'all can see what I saw.
I can just drop a, UseCache. Maybe that'll do something. I don't know. Will this do anything? I don't know. Let's find out. So let's say, for example, I didn't want this to be dynamic and I actually did want to cache this. You might have seen a function that looked like unstable cache previously. And what we're trying to do next is figure out a better version of this. So now you notice when I reload, it's cached. Reload as much as I want. This is unstable cache on steroids. This is, again, super experimental, super early, not ready to be dog-fooded, not ready for anything. But I just want you to know we're really thinking about this.
Use is here. I know that the memes are nonstop, but this is very exciting. I want to walk through what this caching looks like now, how this works, and hopefully show you guys why this new model is actually going to be really exciting. There's a decent chance this video goes out of date as soon as the announcements happen because I'm trying to reverse engineer all this stuff, but I'm pretty confident with my reverse engineering here, and I think you guys are going to like what I have to show you. First, I think it's worth looking at this demo that Guillermo posted in September. Next.js upcoming cache simplifications yield the simplest, most beautiful code. You might be thinking, you yapped about this already, so what's new? So here's the code example. We have this Pokemon list component that renders Pokemon rows that were fetched from DB with this order by random call. This code is dynamic, and we would want it to be because we would want different Pokemon to come in on each refresh. That's the point of having it be random. The demo illustrates two things. One, it has a really fast initial loading screen, and it has really fast dynamic data streamed from a typical regional database via Postgres. So if I open this, you'll see the page loads instantaneously with the empty boxes, and then the Pokemon all come in. The only slow part is loading the PNGs. But it loads the actual HTML for the page instantaneously. And you would expect there to be a lot of code here managing that. So let's look at it. Page.js. Nothing here about caching. Okay. Layout. Nothing interesting here at all. No mention of caching or fetching or even suspense. There is no suspense boundary here. There is a suspense boundary, though, because between layout and page, if page is blocking, it can throw the loading.js state in the interim. This should also be JSX, not JS. Come on, Guillermo. But here we have the loading.js, and this will create the loading state with all of those same list elements, but with nothing in them. And then once they load in, this content from the loading.js gets replaced with the page.js content, which is the exact same content, but with the actual Pokemon inside of it. So how does this work? How is it getting something static? Because if we look at the network tab, it's only going to get more confusing because what's happening is all part of this first request. I'm going to grab this content and we're going to throw it in my IDE. So here we see in the HTML that we have all of those invisible loading divs here. So that's what the HTML responded with. And then some suspense stuff where later on this gets streamed in. But the important detail is everything before here comes immediately from the CDN. And then the updated content comes in after as part of the HTTP stream. But how does it know where to do the separation? How does it know to cut off here effectively and you can just delete everything underneath it so that it can send this complete page? How does it know what parts are dynamic and what parts are static? They have an interesting way of knowing now that I think is way simpler and honestly is pretty smart. They're taking advantage of one keyword that already has a lot of the behaviors that we're looking for. Await. Await is the key to figuring out what is dynamic and static. And it's actually quite genius once you realize this. It significantly reduces the complexity here. This change is what got me thinking more deeply about what's going on here. The async request APIs. If you didn't know before, you could just call cookies or headers or some of these helper functions from Next without awaiting them because there was all data that was in the request that was hydrated through async local storage. So everything could access it effectively immediately. It's almost like they put it in local storage. This await isn't there because this is slow or because this is async. This await is effectively here as a keyword that paints this function as dynamic. As soon as the function is async and it has things in it that are awaited, the next compiler can now assume that this component has to be dynamic. Very interesting change because previously you would have to either tell Next or they would infer it through weird things. Like the example that Guillermo had here, previously he imported headers and just called it and did nothing with it. The reason he did that was to tell the Next compiler, hey, by the way, this component's dynamic. This should change on every render. This should, every time someone loads this page, you should update it. You should send a new response. Now you don't have to throw a random call like headers or cookies in. You don't have to mark the file as export const dynamic as force dynamic. Just by it being async, they now know that this is probably dynamic. But what if it's not? What if you're reading from file system? What if you made a blog and you have to read a markdown file in order to transform it? Those aren't changing. There's going to be a lot of scenarios where the thing that you're doing async await for doesn't actually change. And that's where the UseCache comes in. UseCache is effectively trying to cancel out the async here. So if you think of async as this is dynamic, it needs to be updated every time it's loaded. UseCache is wait, take whatever this generates and throw that in the cache instead, which means that at any point in your render tree, you can opt out of it being dynamic or opt into it being dynamic with the async call. It's actually really clever. There's now two simple ways to indicate what should or shouldn't be cached. Async means that it should be dynamic, and if there is no async call, it will be static. But if you call UseCache, it will now be smart enough to cache the result of that, so you don't have to throw it in a KV or deal with it your own crazy way. It just works. But if you have things you don't want to have static, you just don't put it. So if we wanted Guillermo's example to be static, you just put UseCache here. That's it. Super nice. I'm actually very excited for this. This also makes things like partial pre-rendering way easier because it just goes until it hits an async boundary. There's some really good questions to ask about this. I already see chat asking a bunch of them. Is there a way to tell it when to invalidate the cache? I'm sure there is, but I haven't found it through my shallow digging yet. How do you make the component dynamic if there's no async calls? I think you can just mark the component async and it's fine. That said, I don't know, because honestly, I just don't have examples of dynamic components that don't do something async. I feel like every time I have a dynamic component, it is async in some way. It's hard for me to imagine a case where that's not the case. I did find some fun warnings that seem to confirm my suspicions. Like in this file, the next request and UseCache error file for the docs, the titles cannot access cookies or headers in UseCache. So if you call UseCache in a function body, like at the head to mark it, and then you do things inside of that function that are user request specific, like cookies or headers, these are specific to a given request. So if you use cache on a function that called cookies, you're now caching a result for one set of cookies for everyone, which is bad. You should not do that. If you need the cookies to figure out which user you're rendering for, you're screwed. So they give an error when you try and do that, which also, by the way, is awesome, because when you're wrapping something like unstable cache, detecting these types of things is non-trivial. But if you have a simple UseCache flag, it's much easier both at compile time to check, but also at runtime to detect. They call it exactly what I was suspecting here, which is that this is not supported because it would make the cache invalidated by every request, which is probably not what you intended. Yep. This does hint at something else really cool, though, which is automatic invalidation. You can use things like which props are passed to determine if a cache is valid or not. You can use things like calls you make in there with lifecycle stuff, and I'm sure we can find some of that if we dig far enough. We did some digging, and we figured out how they both expect you to do tagging and revalidation. So let's take a quick look. Here's an example with cache tag coming from the Next.js. Get cached with tag. So this is a function that is marked as UseCache. By the way, it's not just components you can mark, in case that wasn't clear. You can mark individual async functions, and as long as every async await call that a given page or component makes is UseCache tagged, then it will still be able to mark this effectively automatically as cached. This is just function painting all over again, if you're familiar. The idea of like how when you have one function that's async, everything calling it has to be async now too. This is very similar, but the opposite. If you want your caching to be on so that this route can be served from a cache entirely, you have to make sure the whole path is UseCache friendly. You can put it really high up. You can do it in all the lower parts. This is my assumption, but my guess is that this would be a cached page if all of the await calls it makes are also flagged as UseCache, and you wouldn't have to call it on the page file as well. I might be wrong. They might have you UseCache on every layer, but my guess is that if every await that a given async function is calling is UseCache, then they will flag this as cached as well. Possible that I'm wrong here. Probably the single thing I'm the least sure of thus far. That's my guess. What's important here is we're calling cache tag. So now we have marked this as tagged with this specific value. So we could theoretically invalidate this cache tag, and it'll bust any UseCache functions that call cache tag with that specific value. Very handy. It's similar to the revalidate tag, but I like the clearer call of cache tags. Also, the removal of this being on the path side is nice, because the weird blurring of the lines between tags and paths was obnoxious to keep track of. Now it's much simpler. But that's only half the story. We have to talk about the cache life too. They did a great job commenting up this file, so let's read through it. Similar to the cache tag function, they're exposing a cache life function that you can pass an object for what you want the cache to do, how you want it to behave, how long you want it to last for. So here you can tell it how long you want the client to cache a value without checking the server, which means when you go to the page, do you want the client to have that, or do you want it to go to the server instead? Very nice for having those super, super quick loads and everything on pages you've already been to. Separately, they have revalidate, because these are different. Stale is how long can the client keep an old value. Revalidate is how long should the server hold on to a value. It's also worth noting that stale values may be served while revalidating. So if you hit a case where the validation is old, like let's say you have a page like the demo that Lee Rob did where it shows you the time that it fetched from an API. If it is set to revalidate 10 seconds, and you check it 5 minutes later, you're going to get the old value the first time because it's revalidating in the background. But then the next time you'll get the new value it generated during the first request, even though the first request is responded to with an old value. Traditional SWR, stale while revalidate, but it's cool they call that out here and they give you the option to revalidate. It'd be cool if they told you if it was seconds or milliseconds, but this isn't meant to be code that we're consuming yet. I'm sure this will all be in the real docs, but we're reverse engineering right now, boys. Also worth noting, they have an expire option here. In the worst case scenario, where you haven't had traffic in a while, how stale can a value be until you prefer to de-opt and just do it dynamically? Also note, this must be longer than revalidate. So let's say we use the time example again, and we never want you to see a time that's more than 30 seconds out of date. We might set revalidate to 10 seconds, and then we can set expire to 30 seconds, which means, hey, just because we have a value in cache doesn't mean we can use it. We are past the window of safely using that value, so block on the user's request until we have generated the new one. Very interesting stuff. And to be able to call this anywhere, you just write UseCache at the top of a function, and then you call cache life with a number, and you're good. They have a crazy validator in here, but I think you get the point. This new system is really interesting. It throws out a lot of the more annoying steps. It makes clarity around what is or isn't cached and what is or isn't dynamic significantly better. And I hope this comes with the dev tools that we need in order to have a great experience figuring these things out and debugging them as we implement them. Because that was always the missing piece for me. But now that I'm seeing this, getting more excited. Oh, interesting. Apparently in the tests, they let you call magic keywords. So here they're calling cache life with the word frequent. Interesting. Oh, cache life profiles, huh? Interesting. Okay, you might not be configuring that directly. You might have some helpers. But now I'm more confused how they actually expect us to use this cache life function. Very, very interesting. Seems very committed to this idea of profiles with cache life. And you can create your own. Yeah, you can create your own in the config. That makes some sense. So if I go in here, experimental cache life. Yeah, profile. You define the profiles here and then you call them. Very interesting. So for the example we just saw, frequent, and we have the options expire, revalidate, and stale. So we can not give it a stale value. We'll give it revalidate 10 and then expire 30. Okay, I want to play with this whole thing. Who am I fucking kidding? I can't help myself. So let's just kill all the content here. Get time from world time API. Cool. Let's see if this works. Cool, it does. And it's getting the current time. You can tell because that is the time for me. But I want to play. I want to use these new features. So let's turn on DynamicIO. IO true. What was the other feature? I saw that Lee Rob had it in his thing. Is this PPR that he had on? Yeah, it's just PPR he had on. Cool. So now that's on, this is going to error because it's getting dynamic data. I didn't tell it that it can cache the route. Why is it not? It should be yelling at me for doing things. Oh, it's because I'm not building. That's why. It's only in build. PNPM run build. And build should error because I'm doing an await call without giving it a suspense boundary or marking it as cacheable. Yeah, so we get this error because it doesn't know what it can or can't do with that. Yeah, we performed an IO operation that was not cached and no suspense boundary was found to define a fallback UI. Yeah, that's what I expected. But if I use cache here, it's yelling at me for not using client. That's hilarious. Get with the times. PNPM run builds. Why is it mad? Oh, it's still mad because it needs a loading state. Even with or without UseCache, it can't do that at build time because it still is treating this route as static until I give it a reason for it to not be. So if I give it a loading TSX, now it will be less mad that it's dynamic with or without the caching. So I'm not actually sure. How do I tell it, hey, generate this statically still? I almost think there's going to have to be like a use static or something in order for the compiler to be able to optimize this at the right time. Happy I decided to play with this because I'm learning. Cool. So we have use cache. And now if I start the built version, we get a server error. Default cache life profile must always be provided. Let's go provide a default. All the values are optional though, right? Cool. And now we see This data is never invalidated. It's always hitting that cache. If I Command Shift R, you'll see the loading state comes in for just a second because it's blocking. I can even prove how rough this is by doing a async function wait for. Oh, wait for. We'll do 2 seconds. And now it's immediate because it's hitting the cache for the value. But if I remove the UseCache call, and now I have to rebuild and rerun, and now every load you'll get the current time with that delay. 447.49, refresh, 447.53. And now UseCache will let us skip that whole thing. So we'll call unstable cache life with frequent. And now that that has been called here, it's going to revalidate more frequently. What do we put the times on for that? You had 10 seconds and 30 seconds. Perfect. That'll be a good demo. And now on the first request, it has to generate that cache data. And as long as I refresh quickly, you get that value back immediately. But if I wait the 10 seconds, which should be up nowish, interesting that it gave me the loading state. I thought that it would be revalidating there because the expiration is the one I have on 30. So I didn't wait 30 seconds there. Okay, like waiting a few seconds. Oh, it would have been 30 from the start. Cool. So this value is now old. I could wait. I could show an actual ticking clock, but we are more than 30 seconds past, which means it will not show me the cached value. It's going to expire the cached value. So now we have to wait on the loading screen. But if you sit here and refresh often enough, you'll see a really cool thing happens. It's going to just bump to a different time. Or not. I thought that it would have revalidated in the background and done that. Interesting. That's not the behavior I would have expected. It's possible it behaves different like on their servers in production, but I would have thought the revalidate would give you the stale version as it recalculates in the background instead of putting you on the loading state. Yeah, SWR might just not be working locally or in self-hosting, or it's just not done yet, but I see what they're going for here. Very interesting. Someone asked, why do they allow UseCache on page? Because they allow it on any async function. That's the whole point. It's actually really cool that they allow it on components. I love that. I think that's one of the best examples. Not this here, but I think the fact that you can use it on a component like I was here is one of the coolest parts. Another fun example here is if I put UseCache on just this slow function, just this wait for, and then we go rebuild. I didn't put the UseCache, or I didn't put the cache life function there. It's nice that those errors all actually work, actually. Cool. So I removed the unstable cache life call from here. I put UseCache in the wait for. Now, the slow part is cached the first time it has to load. But now, even when it's getting data from the server, even though this time is going up on every refresh, that slow part, which was this timeout that takes 2 seconds, it will never take 2 seconds again because we cached that part. So it's no longer slowing down this part. And that's what's really cool about this pattern. You now have the ability to move where the cache happens that simply. If I want to bump the cache up to be at the page level, I just put UseCache here. If I just want to cache this one slow part and let the rest be dynamic, I move it down there. That is really cool. I see the huge DX win here because caching isn't a thing that I should have to think about while I author the function. It's a thing I should add when I want the function to be faster. And wrapping with unstable cache, passing it all these keys and making sure all of those things work how you expect sucks. And this doesn't. I actually think this fits better than something like useServer. I'd almost rather useServer be a wrapper and UseCache be a tag like this. I actually quite enjoy it. I'm coming around. This is going to be so much better. So Ryan, they can get this added to solid before they release it? Actually, though, I think this is another one of those really cool primitives that the React team came up with after thinking way too long. And now the whole ecosystem can learn from it. So what you're confused about here is that they're returning something here that is a component. I guess that I might just be like server component pilled, but what I see here isn't so much is caching a component in the cache layer or whatever. What I see is like the payload that triggers what renders in the new React model that is identified by this component is cached. So if this is an async server-side component, then it will generate and be put here. If this is a client-side component, then when you render it, it will do all of those things. Yeah, this is a very interesting paradigm. I don't personally find this confusing, so it's hard for me to like clarify, but it's the equivalent of like if you ran this function, what would it have done? That's how UseCache works. It's really simple. Does it work on client? Asks Ryan. No, it does not. Just server. This is a better caching primitive for server-side functions and async functions on the server. For those who don't know, Ryan's the creator of Solid.js. Phenomenal framework. The only thing I would consider other than React at this point in my life. And historically, he's taken a lot of advantage of cool things that Next and React do and how they improve things like the editor experience in order to copy the cool parts and bring them to Solid and Solid Start, be it JSX and async stuff going on in the JSX world, be it use server and use client as declarations that a lot of compilers recognize now. So I was curious what he would do with use client, and it's not something that necessarily makes sense for them because it's just function caching for him. But for server components, this is huge. I'm into it. Yeah, copy and improve. Yeah, absolutely. Well, you've used deeply inside. You can't use it inside of a client component because a client component can't call an async server function like that. What you could do is have a server action, or I guess a server function, now that they're called that allows you to, or that you can use cache, and then when you call it, you're hitting an endpoint that's cached effectively. Because it doesn't exist yet. We're speculating on the future of Next. That's why you can't find docs, because this isn't real yet. This is all deep in their source code for stuff that's going to be announced in a week or two at NextConf. It's not even alpha. It's not announced. That's the whole point. We're speculating on the future. So work on server functions. I can check that somewhat quick. Client component.tsx, server action.tsx, use server, client. Click equals. And I'll mount that on the page. I'm just going to make this is fine with me. Kill all that. It's going to be mad I'm not using these, whatever. We'll just comment them all out. pm run build. This is without the cache to start, just to make sure it works. I know that they're planning on getting it on routes if it doesn't already work, but my curiosity is getting the better of me. Why did that not? Oh, I guess catch is what I meant. I'm dumb. Been doing too much of my favorite effect lately. Oh, that's annoying that those all just came through now. What the fuck? Okay, it's working now. I just needed to refresh it. No idea why. Cool. So here we see 1659.45, 1649 or 59.48. So it's going up. It's changing. But what we want to see is what happens if I use cache on this. Interesting. Is not allowed to define inline UseCache annotated cache functions in client components. So this isn't a client component. Is it that I'm calling it in one that it's mad about? Yeah, it's import tracing. So the client component calls the server action, which has the UseCache on it that it is mad about. But if I was to make like API/route.ts, we wouldn't use server. Well, I have to kill that there for this to build. Oh, it's not a valid get return type. That's actually a good error. It has to be a response. I'm dumb, okay? Only plain objects, a few built-ins can be passed to... Nope, that's not the right error. Interesting. If I separate this out... Haha! I've outsmarted you, Next compiler. And now... we get a cached value hitting an API endpoint. That's actually really cool. That's really cool. I see the vision here. Obviously, we don't know all the details. Anything I have said thus far could possibly be wrong, but we even got Ryan enjoying this. Is it a global consideration? It is. And I am very excited to see where things end up. The future is bright. The future is cached. And for better or worse, the future is probably still on Next.js. So let me know what you guys think. Did you enjoy this reverse engineering? I did my best to figure this out, and I hope this is helpful to y'all. Until next time, peace nerds.